We have to find the coordinates of the incenter formed by the lines x plus 2y minus 8 equals to 0, 2x minus y minus 1 equals to 0, and 11x plus 2y plus 32 equals to 0. All these three lines together are forming a triangle. We need to find out the incenter of this particular triangle. Now we will use the concept of finding out the equation of angular bisectors and then finding out the point of intersection of angular bisectors. Recently, we have done 2 to 3 videos on this, so you can just go through them if you are new to this topic. If you are already known to this, then we'll be doing this very quickly, try to finish it fast. Now, what is the equation of an angular bisector? Comes from the concept that the angular bisector is equidistant from both the lines. Angular bisector of a particular vertex, the angle divides the angle into two equal parts, and that line is equidistant from both the lines which are making that angle. And also we have two angular bisectors. One is acute angular bisector, another one is obtuse angular bisector. Now depending on the problem, we have to choose that angular bisectors which will fit into our requirement. And what is the formula for that? We know the formula is, if you have two lines, a1x plus b1y plus c1 equals to 0, and another line a2x plus b2y plus c2 equals to 0, then the angular bisectors of these two lines is given by a1x plus b1y plus c1 divided by square root of a1 square plus b1 square equals to plus or minus a2x plus b2y plus c2 divided by square root of a2 square plus b2 square. Now we are using plus and minus because we will have two angular bisectors. Now let's go ahead and do that. The same logic we'll try to apply here. First we'll take equation 1 and we will take equation 2. Now that means we are looking at trying to find out the angular bisector. This angular bisector we are trying to look at. And one way to understand which one is the appropriate one, you can see that this line is cutting y-axis at 4, intercept is 4. Here it is between 0 and minus 2, that is minus 1. So whatever the line I am going to get, its y-intercept between should be between minus 1 and 4. Then that is the line which I am looking for. So that logic we can use here. Let's go ahead and write down the steps. First one, for the line 1, I'll write down x plus 2y minus 8 divided by root of 1 square plus 2 square equals to plus or minus. Second line is 2x minus y minus 1 divided by square root of 2 square plus 1 square. Now these two are both are same, so we can simplify that. So we have two equations. One is x plus 2y minus 8 equals to 2x minus y minus 1. Another one we have is x plus 2y minus 8 equals to minus 2x plus y plus 1. Let us see. The first equation is giving us x and minus 3y, and this will be minus 7. So we have x, 2x minus x is x, minus y minus 2y minus 3y. This minus 1 will go that side. One equation we got is x minus 3y equals to minus 7. What is the y-intercept of this to find out? Very simple. Put x equals to 0. When we have x equals to 0, we have y equals to 7 by 3. That means exactly it is coming between 2 and 3. So that line seems to be the appropriate one, because we check the other one, what is happening. We are having 3x plus y equals to 9. See now the y-intercept of this. If you put x equals to 0, y equals to 9. That means this line, this second line, 3x plus y equals to 9 is going in this direction. It is cutting at 9 somewhere here. And the first line is coming in this direction. So you can see very clearly, it's very easy to understand from the graph once you have the diagram. So we have our first angular bisector equation with us, that is x minus 3y equals to minus 7. So I'll write down here x minus 3y equals to minus 7. And when x equals to 0, y is 7 by 3, 2.33. Somewhere it is cutting. So that is how that particular line is coming. Okay, right. Now let's go to the next angular bisector. For that we will take 2 and 3 we can take, or we will take 1 and 3, and we'll find out another angular bisector. We'll take 1 and 3. So I will write down x plus 2y minus 8 divided by square root of 1 square plus 2 square equals to plus or minus 11x plus 2y plus 32 divided by square root of 11 square plus 2 square. Now, when we simplify, we see that this is root 5 and this is root 125, that is 5 root 5. So you are left out with 5. This is root 5, and the other side we have 5 root 5. So I can write two equations now. One equation is 5 into x plus 2y minus 8 equals to plus 11x plus 2y plus 32. The other equation will be 5 into x plus 2y minus 8 equals to minus of 11x plus 2y plus 32. Now, let us see the one. If you look at the lines 1 and 3, now line 1 is intersecting at 4, and this line will be intersecting at 16, so minus 16. So it should be between 4 and minus 16 y-intercept of the line whatever we are getting. So let's go to the first one and check it now. We will have 5x plus 10y minus 40 equals to 11x plus 2y plus 32. That will give us 6x, then minus 8y equals to 6x minus 8y equals to minus 72. So look at the y-intercept of this. If you put x equals to 0, we are getting 8y equals to 72 or y equals to 9. That means this particular line will be going in this direction because it is intercepting the y-axis at 9. So this is not the one what we are interested in. We have to go to the next one. So let's go to the next one. Let's open the brackets. We'll have 5x plus 10y minus 40 equals to minus 11x. Then we have minus 2y minus 32, or can I write down 16x plus 12y equals to 8, or can we simplify by dividing with 4 and say 4x plus 3y equals to 2. That's nice equation we have. 432, 4x plus 3y equals to 2. So that's our second equation, because you can check when I put x equals to 0, y is 2 by 3. 2 by 3 is somewhere between 0 and 1. So this is the perfect line. That is what we need. So 4x plus 3y equals to 2 is our second equation. So we'll write down 4x plus 3y equals to 2. So once we got our both the angular bisectors, now we can go ahead and try to find out the point of intersection of them. So one equation we have is x minus 3y equals to minus 7. And another equation is 4x plus 3y equals to 2. Good news is we don't need to multiply with anything. We just add them. We get 5x equals to minus 5. That will give us x equals to minus 1. If x equals to minus 1, then 3y is nothing but x plus 7, that is minus 1 plus 7, which is equals to 6. That will give us y equals to 6 by 3, that's equals to 2. So the point is minus 1 comma 2, that is our in center. We can also draw the other angular bisector which we got. Now you can see that both of them are exactly intersecting with each other at minus 1 comma 2. So that's the coordinates of the incenter.